Hi, everybody. Welcome to the 1.5 topic questions video. I imagine that a fair number of you had a little difficulty with 1 and 2. And if you are totally great with 1 and 2, then the next couple of minutes might be a little boring for you. But I suspect most of you, if not all of you, need a little bit more discussion on 1 and 2. Now, let me give you the big picture. These composite functions with limits, these questions generally show up on the multiple choice portion of the AP exam, and there's usually one of them. At least that's what we've seen in the past 5 years or so. So I want to kind of put that in perspective for you. You're not going to ever have a test from me with 10 of these on there. And you're not going to I can't say for sure because I don't write the College Board tests, but you're very unlikely to have more than one or so, maybe just a couple of these on the AP exam. Okay, but having said that, it's not necessarily a hard problem. Now, one of the things that confuses people is just taking the limit of a composite function. So I'm going to completely break this down. If you are bored, feel free to, kind of fast forward a little bit. I don't want to assume that everyone is bored. So when we see the limit of a composite function, we generally try to take the limit of the inner function. Remember, when we do a composite function, like f of g of x, I'm just going to write up a generic one here, kind of in my chicken scratch. We generally take the inside function, we deal with that, and we put it into the outside function. So we always start on the inside. This is no different, okay? The only difference is we're taking the limit instead of actually composing two functions. So it's going to seem a little bit more awkward. So if I were to take this limit, let me rewrite this, and I'll show you some words here in a minute that are written a little nicer than my writing. And I were to put that inside. Okay, so the limit as x approaches -1 of f of x. Well, if I tried to put -1 into here and do a direct substitution, we would find out that that does not exist, right? That's a problem. But we can look at it from the left and from the right. We can say, okay, coming in from the left, the limit is approaching 3, and coming in from the right, the limit is approaching 3. So that's helpful. That's helpful information. So now we have a little bit of an issue, because if we replace this inside, we figured out this limit, we can substitute that. We can say, okay, that's going to be 3. And why is that? Because the limit as x approaches -1 of the function f of x is 3. See how the left-hand limit and the right-hand limit agree. They're both approaching the same y value. So we can do that. But the problem here is that we really haven't been specific enough. It's approaching 3, but it's approaching 3 from lower values, okay? So I want you to keep that in mind for just a minute. So what a lot of people probably do here is they say, oh, okay, well, I know f of 3. Here's a very nice closed dot, right? And that's about 1/2, and bam, 1/2 is an answer choice. And a lot of people pick 1/2 here. But unfortunately, this is a little bit too general. Okay, this f of 3 is not entirely correct, because what's happening here as the limit approaches -1, let's just go back to this initial stage. As the limit approaches -1, it's coming from lower values than 3. Okay, so it's approaching 3 but from smaller values. So what we have to do is we have to say, okay, well, that's kind of like approaching from the left, right? If we're approaching from a smaller value or underneath, that means we're approaching 3 from the left. Okay, and we still have to take the limit, right? We still have to take the limit of that function. And I'll show you what the College Board does in a minute. I'll show you their terminology. So what we really need is this one. We need the left-hand limit of 3, not the function value. So we want that -1. And it might not be completely clear right now, and I get that. Let me, I don't think I can show, I didn't cut and paste that. But let me show you some notation here. So in general, if we have the limit as x approaches a of f of g of x, that is the same thing as what I just did, putting the limit inside and taking the function value. But I'm here to tell you that only works when the limit as x approaches a equals a particular value. Well, we had that because the limit as x approaches -1 was 3. So we had this particular thing. Put a little check mark here. But this other condition has to be in place. F of x has to be continuous at that value. So in our case, let me just write in here what this would look like. So the limit as x approaches -1, now ours was f of x, so I'll just write f of x, was 3. And f of x is continuous. What's this L value? At 3, right? We lose on this condition. That limit, that L, that 3, if we look, it is not continuous at 3. It's got a jump, what we call a jump discontinuity, and we'll talk about that more. I'm not expecting you guys to know what that means, but think about if you're drawing the graph, you would have to draw your pencil here and then take your pencil off the paper and jump up to here and then keep drawing. So 3 is not a point of continuity for f of x. So unfortunately, this whole thing kind of got thrown out the window, so to speak. So I put this little phrase down here. It is important to consider, in that case, what direction, this is what I was talking about those lower values, what direction the inner limit value is approaching. Okay, so when it's approaching 3, is it approaching 3 and getting smaller and smaller and smaller and approaching 3? Or is it coming from lower values and approaching 3 from underneath? And in our case, it was approaching from lower values, which means we can't just do f of 3, okay? We have to do, because it's lower, we have to take a left-hand limit. Now, if it was bigger values of 3, we would take a right-hand limit. And that would give us the -1. Let's take a look at the picture again. So as we approach 3 from smaller values of 3, which is what was happening over here, we're approaching -1. So we could not do this. This part was actually erroneous. And I wrote that on purpose. I mean, in a normal situation, if it had been continuous here, you would have been able to do that. And that would have been just fine. Okay, let's take a look at another one. Let's take a look at number 2. So number 2 says, it's the same concept, just a different graph. So the limit as x approaches -1 of f of x. So let's write down what that would look like in an ideal world. Okay. So as x approaches -1 from the left and from the right, the limit is 2. Okay. So in an ideal world, f of 2 would give it to us, but it has to be continuous at 2. Is it continuous at 2? No, it's not. See, here we have a jump. So I would have to lift my pencil up. So then my question is, okay, let me put a big X through this. Can't do that. So now I have to look and say, okay, well, when I do the limit as x approaches -1, when I calculate or observe that, is it coming from lower values or higher values? And you can see here that it's coming from the y values are getting bigger, but they're smaller than 2. So again, this is going to be a lower approach. So it's going to be a left-hand limit. And let's take a look at the graph. Let me scroll back up here. Okay, so as we approach 2 from the left, we get 5. Very tricky, those problems. In fact, sometimes I have to stop and think about them. Really get. Now, if this had been continuous, we would have been done over here. We would have been f of 2 and been done, because both the left limit and the right limit would have been that function value had it been continuous. But they gave us some very nasty little graphs. Okay, so let's move on to some different kinds of problems where we're doing left and right limits, but with a piecewise, and you have no graph. So the hard way to do this would be to graph the piecewise. Okay. The easier way to do this is to look at the piecewise and look at the limit that you want to calculate. So in our case, we would like x approaches 2 with a plus, and that means from the right. Okay, so think about what this piecewise would look like. You'd have something to the left of 2, you'd have something at 2, and you'd have something to the right of 2, right? If you look at that number line, just the x-axis, you would have piece 1, you would have 3, and you would have piece 3. So if we want to evaluate the limit of f of x as x approaches from the right, we want to look at this right-hand piece that is to the right of 2. So the only piece that we need to worry with here is the x squared minus 4x plus 8. And because this is a polynomial, and polynomials are very friendly critters in mathematics, we can take that 2 and we can do a direct substitution. So we'll have 4 minus 8 plus 8. So those will cancel out, and we'll be left with 4. So the big issue there is just picking the correct piece to evaluate. And after that, it feels like an algebra problem. Really nice. I think there's one more here. Yeah. Okay. So this was also a 2 from the right. So I think it's pretty obvious then that we're going to be, again, evaluating for x plus 3. Now, if it was a left-hand limit, we would do this first piece. All this is the 0.29. We don't want that. That's just a function value. So if I had to label this, I would label this left-hand limit, right-hand limit, and function value. That makes sense a little bit. So what I'm going to do is I'm going to take 2 and I'm going to plug it into that last piece. So 4 times 2 plus 3 is 11. Okay. Now 5 and 6. I think those are the last 2 problems, right? Yeah. I feel like they tried to trick you here. Okay, so you're using your properties of limits. You can take the limits of sums, of differences, of products, and of quotients. But I feel like where they tried to trick you here was here. I don't think they gave you anything, excuse me, that required function values. I think they wanted you to pick those things because they wanted you to think, hey, I can do direct substitution. Same thing down here. But that's not the case. If you look at the expression, it says the limit as x approaches 3 of all this junk. And you have an h of x times a quantity. So I'm going to write this out, especially this one, just because it's the first one we're doing. So there's my h of x. And there's my quantity. Now I can write this out even more, and I'm going to. You won't need to once you get a little more familiar with it, but I just want you to see, let me get that last paren in there, what this actually looks like, completely expanded. And that way you'll understand why you cannot use those function values. Unless it actually said like something else with a function value. So here's my limit as x approaches 3 times, and I'm going to put like brackets here. Okay. So I'm going to have the limit as x approaches 3 of this piece plus the limit as x approaches 3 of this piece. And I'm going to try to close this bracket. I don't have a lot of room there. Okay. Now, there's one more thing I can do before I start plugging stuff in. Now, maybe a lot of you guys, you can plug this in now, and that's fine. That's fine. I just want to show you what it looks like. So here's my h of x just sitting out here. Now, the only other thing I can do to make this a little easier on myself is this. Let me circle the 2 and circle the 3. Those are constants, and the limit of a constant is itself, because it's like a horizontal line. The left-hand limit and the right-hand limit are the same. So what I'm going to do is I'm going to pull the constant out in front like a coefficient, because it's really just a multiplier. And I'm going to pull that 3 out. Now, some of you might have done this a lot simpler. That's okay. I'm not upset about that. I'm just doing this so that you guys can see step by step by step why I cannot use those function values. All I see in here are limit, limit, limit. I do not see a function value standing by itself without a limit. So all of this stuff here in the first column is off the table. I can't use any of that. So now let's do the limit as x approaches 3 of h of x. Well, we know that. The limit as x approaches 3 of h of x is 2. Inside, we're going to have 2 times the limit as x approaches 3 of f of x. That's also 2. Then we'll have 3 times the limit as x approaches 3 of g of x. Well, that's 8. So now we just have to do some math and remember our order of operations. We'll have 2 times 4 plus 24 is 2 times 28, which is 56. And that's where that comes from. I hope that makes sense. And it feels like a lot of writing, right? But I wanted to do that writing for you so that you could see one all worked out. Now, this next one is very similar. I'm going to go ahead and write it out, but I'm not going to do every step with it. I'm going to do the h of x. Very similar, though, to give you some confidence there. see here. Right. I'm just jumping to that last step. Hopefully you can see what I'm doing. Oops, I forgot my 2. Sorry about that. Okay, so this is what I got to in the previous problem after showing you like 2 or 3 steps. What I just did here was I jumped to that last step. So now I can grab the limit of h of x, 5 times the limit of f of x, plus the limit of g of x. Okay, so that'll be 2 times 20 minus 6 is 2 times 14, which should be 28. And yes, it is. So I hope that helps. I know those first couple of problems were kind of dicey, but just keep in mind, they're not huge, but they're tricky. Thank you.